Hello, hello. You're welcome to our the continuation of our discourse on data science using Python. All right. So, to open your Python, you can go to the Anaconda um app itself or Jupyter Notebook here. So this prompts would generate so, some codes, and then it will either bring up your browser by default, or you have a code you can copy and paste on your browser so that I can use your Python scripts. You can see mine, it brought it up automatically. All right, so well, this is the script. If it for you, if it does not bring it up, you can copy. So you can, to access the server, open this file in a Jupyter in a browser, or copy and paste one of these URLs. So you can copy anyone and then go and paste in your browser, in any browser. All right, so now I can access my computer here, and I know my folder is in downloads. All right, then this is the folder. So I have my lessons here, my scripts here, my PDFs, then the two data sets we'll be working with today. So I'm going to just double click here to open the scripts. However, if you are interested in opening a new script, you would use this. A new script that has nothing, you use this. Well, here we are opening the scripts 3. So there is a lot here, and so we'll move fast. I've added a whole lot of things to what we did in the last class. All right, so here we're talking about libraries, data cleaning, and table operations in Python. All right, so we'll be focusing on NumPy and Pandas, although we'll touch a little bit on scikit-learn. All right, so the learning objectives, you can read this up. All right, so why libraries in data science? Python libraries are pre-built collections of functions and objects that make complex tasks easier. All right, so just like our normal libraries where we have different books. So you can have books on finance. You can have books on cooking. You can have books, different different forms, different sections of book when you go to a library. The same thing here. So we have different types of libraries. There are thousands. So like I said in the class, the beauty of libraries is that, I mean, Python is the open source where you have libraries every day. New libraries are being released to the market with documentation, so you can get yourself familiar with some. All right, so the libraries we'll be looking at today will help us to clean and manipulate data, perform mathematical operations, load and process files like CSV and Excel. All right, so analyze. We'll do a little bit summary, but visualize will be in the next class. All right, so the first library we'll be looking at is NumPy. NumPy is an abbreviation for numerical Python. Now, not all libraries actually have meaning, like not all library names have meanings. This one just has anyway. So, NumPy library is used for numerical computations. It introduces powerful data structure called arrays. All right, so to bring in NumPy, we okay, to bring in NumPy into the Python environment, we use import NumPy as NP. And if I run this, you can see I have one. That means this section has finished running. So now anytime I need to use my NumPy, I'm going to be using NP. For example, in the next code, we said creating arrays. Now array 1 np.array. So this np is NumPy. and then this is the standard, well, this is the general format which we all do. You can do import numpy as pn if you want, import numpy as q if you want, as anything you want, just for you to remember is the main thing. All right, so but everybody uses import numpy as np. All right, so now for Python arrays, there are two, we're considering two types of arrays: the single array, like the 1D array, and the 2D array. Now, for the 1D array, it's just like a list. Remember, for the Python list, the normal list we did without bringing in libraries, we used um, only the square brackets without this function, without the parentheses, just the square brackets. All right, so that's the array 1. While array 2, you can see array 2 has two square brackets, so it's a list inside a bigger list. So 2D array is array 2. Now this 2D array has 3 rows and 2 columns. This is row 1, row 2, and row 3. So while the one-way array functions like a list, the two-way array functions like is a matrix because it has rows and column. All right, so we are going to run this to see. So we are printing array 1 and array 2. So you can see array 1 is 1 2 3 4, while array 2 is okay. So this is array 1. I mean, okay, I don't want to show array, I just want to show the values. All right, so add a new one and show array 2. So you can see the difference. Array 1 is a 1D, one dimension, it has just one row, while array 2 is 2 dimensions, it has row and it has columns. Sorry for that. Now we can index and slice. So we can index and slice arrays. The first one, we print array 1 0. Array 1, the zeroth, that's the first element, is the zeroth element, which is 1. So if we do that here, all right, so if we do that here, we have 1. I'm creating a new cell for array 2 because array 2 is 2-dimensional. We are trying to return the first row and the first column, the first row and the first column. So looking at the array itself, this is the array 2. The first row, this is 0th row, then this is the first row. All right, so this is the first row, and then this is the 0th column. The 138 is the 0th column, the 245 is the first column. So that means we are where row 1 and column 1 intersect is this 4, so we should be expecting a 4 here. All right, then array 1 prints 1 to 3. So array 1 will print 1 to 3. This is the 0th one, while this is the 1, 2, and 3. And remember, Python truncates at the last element or the last selection, so to give us only 2 and 3. All right, now we can also reshape arrays. Remember, we have array 1 as 1 2 3 4. So we want to, and it is 1-dimensional. We want to reshape it to 2-dimensional. So we do array 1 reshape 2 by 2, and it becomes 1 2 3 4, just like this. All right. Now we can also do operations on arrays. Unlike the other time when we were working on the normal arrays, the normal Python arrays, when we do plus, it concatenates. So if we say array 1 plus 2, it will concatenate, I mean, it will result into array1 printed twice. Okay, so let's do that here. Here we have array1 plus 2. You can see plus 2, what it did was to add 2 to each of the elements. Array1 was 1, 2, 3, 4. So if you add 2 to 2, I mean to 1, you get 3. Then you have 3, 4, 5, and 6. So that's exactly what we have here. 3, 4, 5, and 6. If we do array1 plus array1, we have 1, 4, 6, I mean 1, 4, 6, 1, 4, 9, and 16. Sorry, this is multiplication. So 1 times 1, 2 times 2, 3 times 3, and 4 times 4. That's what it has done. Then we have print the main of array1. So you can see NP. This main value here belongs to NumPy. So print the main value of array1. That's 1 plus 2 plus 3 plus 4 divided by 4. That should be 2.5. Then print square root of array1. Then there's this other one I want to do. Print array1 plus array1. So you can try whatever arithmetic that comes your way. So you can see this is, that comes to your mind. This is the same thing as multiplying it by 2, because you have 2, 4, 6, and 8. It adds them together. Now, for Pandas library, it is used for data manipulation. We use it to import data. Pandas and NumPy are very, very important libraries in data science. Pandas is used to analyze, clean, and explore data in tabular forms like CSV, Excel, or SQL. Now, so import Pandas as PD. Yeah, so it has been imported. In the class when it didn't, I had to uninstall my Python and my Anaconda, then reinstall it back. All right. So so now that Pandas is imported as PD, we can do operations with Pandas. So a series is like a 1D labeled array. So we have PD series. The Pandas dataset is a series. So PD series, we have 10, 20, 30, and the index is ABC. Assigning it to S. If we print this, you can see ABC 10, 20, 30. All right, it's like the dictionary, the normal dictionary that we have considered, but it's just a little bit different. Now, this is usually not so much used in well, I've not used anything like this before, but it's just good to know. Now, creating data Pandas data frame. All right, so we can, since the beginning of this series, we have been talking about lists, different types of data structure. Well, going forward, we'll be using tables, using data frame. Data frames are the relational type of data that we'll be using. That's a table wise, having rows and column. Now, that is easily done and best done with pandas. Now, data equals curly brackets, name, this is the column name, then the age, another column name. So I'm expecting this data set to have two columns. In column 1, put Alice, Bob, and Charlie, while in column 2, put 25, 30, and 35 to correspond with the entries in the name. Then we have um, data equals data dot data frame data, then print df. So here you can see what we have. We have the name and we have the age. The first column and the second column, it has 3 rows. All right. So to load CSV or Excel files, mostly in your data science projects, you'll be working with CSV and Excel files. CSV means comma separated variable. It's just like Excel as well. It's just it can open in notepad. CSV is very common because it is not ambiguous. It only stores the values and comma, while Excel stores the space, all the paparazzis that come with the data. All right, so let's load a CSV file. Okay, this is an Excel file. All right, so this thing is very simple. We know we want to use pandas to load, so we are writing pd because we have imported pandas as pd. All right, so pd dot, if you use your tab, then you would see read Excel among these options. So you can see read underscore CSV, and you can see read underscore Excel. All right, so read Excel, then you can put in your other arguments. For here, look at what I said here, load Excel outside working directory. Now, I said earlier on that the folder I'm working with is in downloads. This is it here. So you can see the scripts for lesson 1, lesson 2, and lesson 3. And then the PDFs I've sent to the group. And then now we have two data sets called customers. One of them is customer.csv with small letter c. The other one is capital letter C, customer.xlsx. All right. So now it is a good practice that whatever you will do, your scripts and your data, if you'll be using any image or anything, you should always put them inside the same working directory. As you should put them in the same folder so that they will be easy to call. So what I did is outside this my working directory, I still put the two data sets there. You can see the two data sets. All right. So I'm going to be showing you how to import the ones inside and the ones outside. So it's left to you to know which one you want to use, which one is simpler for you. All right. So let's go back then. So here we are loading the one outside the working directory. That's Now we are calling it df excel because we are loading an Excel file. It's the same thing for CSV. So for CSV, just change this Excel to CSV and change this as well to CSV. All right. So um, so we have this. So now because this what we want to load, the customer data set that we want to load, it is not inside the working directory. It is outside. If it is outside, then we'll have to bring the address, that's the location, the path, the file path where the document is. We bring it here, then the name of the document, we write it here. Now this R here is just saying raw, like search for it exactly the way it is. Search for it exactly the way this address is. All right, so if we run that, then we want to see what it looks like. That's why I am calling this. Okay, this is kind of too much, but let me just call it. Okay, so we have a lot of. Oh, sorry. No, this is not what I'm supposed to do. So the data set is df underscore excel. So I'm going to run this again. So you can see it's a long thing. It's a long output. We have dates, name, we have age, sex, marital status, hair color, education level, different variables for 34 customers. All right, so you wouldn't want to make your table appear like this in your scripts. It's too big and it can be confusing, so we can reduce it. It can be reduced, and that's the next. Okay, so before I reduce it, let's go to bringing in the other one. So this one I'm going to call it df underscore excel double L. All right, so this time around we are loading from within the working directory. If you are loading inside the working from inside the working directory, you do not need to specify the address, you don't need to specify the path. You just put the name of the data properly spelled. If you are using capital letter, you use capital. I mean, if it is stored in capital letter, make sure you use capital letter, otherwise it will return error. All right, so you see if I run this now, we'll still have the same thing we had before. Let's say still the same thing, 34. So now we have brought in two data sets, one df excel with double L, another df excel with just one L. All right, so now data frame operations. these are popular operations performed on tables. So we want to check the column names. All right, we want to check the column names. Okay. So to check the column names, just write the name of the data dot columns. Once you print it, okay, so I don't have to do print. So just, just call it like that. Then you have date, name, all of the columns in the data set will be returned to you. All right, so now I want to call your attention to something. When you are, okay, it's the same thing though. Yeah, most times when you are working with data set that have space, I mean variables that have space in between, you have to note that you should quote it. You should quote that name. All right, either with single quotes or double quotes. All right, so now we can also print head. Show only a few from the top. So we call it printing head. So by default, if we print df underscore excel dot head without putting any values here, it will show us the first 5 rows. All right, so if I run it, because I already ran it, so I'm having the, now if I want to show the last few entries, df excel dot, so it's going to be, this time around it's going to be dot tail instead of dot head. So by default it will show me the last 5, 34, 33, 32, 31. All right, so it's going to show me the last one. But if I have specific numbers I want it to show me, then I can tell it to show me the last 3. Then run this. You can see I have the last 3 here. So you can play around the numbers you want to show you. So instead of presenting your data like this, you can just always look at the head. There's nothing you want to see in the whole data frame. All right. Okay, now another thing we can do with data frame is to describe it, to show the summary statistics. All right, so I'm just going to clear this output so that clear this output and clear this. Okay, so now to check the summary statistics of your data set, no matter how big, no matter how large, you can just call the data set df underscore excel and then dot describe, for your descriptive statistics. So it's going to bring in everything that is necessary to be described according to the type of data. So you have dates, age, you can see the count of the age 35, the mean is 46, and so on. So now the only disadvantage here is that it does not give us the frequency of the categorical variables. It only gives us the values, the ones with values. That's what it gave us. All right, later on we'll see how to do that with categorical variables as well. Now, for to calculate the specific variables, we have excel, df excel age, that's the column age in the data set, return the mean. I have 46 point something, so you can see age here is also 46.228. The same thing here. Now here, if we want to, this is working with text. We did this I think in the last class. We want to turn all of the name column into uppercase. So if we do that here, you can see all of the names have turned into upper cases, all of them. Before now, you can see have them in normal form, just only the first letter is capital, while others are small letter. Here, converting it, you can convert it to capital letters, everything. Now, to delete a column in our data sets, I'll be deleting from the Excel with the double L. So we use the drop function. So we want to delete the referral column. Axis 1, stating that axis 1 means that it is a column that wants to delete. Then in place equals true implies to change directly to data frame. Make the changes inside the data frame. Alright, so let's see where referral is here. Before, so referral is second to the last column. Now by the time we run this and then call the data, you can see second to the last column is now width. Referral has been removed. Now to create a new column by adding a new column. Now from we have revenue in thousands. I want to create a new column here and have revenue doubled by multiplying every item in this column. To do that, I select the revenue doubled, which is the new thing I want to add. This is the new column I want to add. Then I give it the prompt that the revenue 1000, which is the existing one, multiplied by 2 should be assigned to revenue doubled. Alright, so if you click the first two, check the first two, you can see we have revenue doubled here now, which is the multiplication of everything in the revenue in thousands by 2. Alright, so for the sake of information not being overloaded, we'll be stopping here. Then in the next class we'll continue with handling missing data. All right, so thank you.